Polarity. It's different polarities. We have to small
Good morning, good morning, good morning. Okay, so the majority of our time will be part 2 of our oxidation reduction titration adventure, but we absolutely have a little time to address a question on gases. So we were looking at some multiple choice yesterday. I would love for us, so in our packets, we were taking a look at these multiple choice questions. What, they were like 7 pages in. Well, if we turn another 4, we will find this. We have not talked about polarity of molecules yet, and so C is taken out. I'm so sorry. Can you see that the pages were copiers? All right, so make sure that you're not skipping over this initial information given. That's pretty necessary. Can you, let's take 4 minutes to answer A, B, and D. You absolutely can lean on each other. You can ask me things. If you want to take a look at, the poignant things that we put on that yellow sheet yesterday. So let's answer these with quality, no need for quantity. All right, dig in. Bless you. I would encourage us, if that helps you, to just nail free response questions, is that CER method. So what is the answer? Are we good to go over A and B? What is the answer? CO2 for this first one. Okay, so they just have to be there. Sometimes we write that first if you want. That's why CER. All right, so what is the explanation? All of this, or the evidence rather. I'm so sorry. So you're given this information. So per P equals nRT, if pressure, volume, and temperature are all the same, then moles have to be the same. If you have all the same moles, but they're not all the same gas, well then, if we just take moles, which will be the same for all of them, times their molar mass, we'll get the mass that we have of each. Well, if they all have the same moles, then molar mass decides it. So this would be, therefore, the greater the molar mass, the greater the mass. And this is part of the reasoning as well, because carbon dioxide has the greatest molar mass of the ones given. That's why it's the choice. Are we okay with? We are so good at choosing the right one and getting the right evidence. It's making sure we bring home, well, what does this have to do with this? So, since they're all the same temperature, they all have the same average kinetic energy, you can just simply say that. We can just know that and trust that to polish it and make it extra sparkly and A++. We could say, per the kinetic molecular theory of gases, we know the temperature is directly proportional to kinetic energy. Since they're all at the same temperature, then they all have the same kinetic energy. So here is, claim, and then here's the evidence, and then the reasoning. Okay. Bryce, did you get to D? No sweat. Do we need more time for D? Just take it away. Go ahead, sir. Why? So, why? All right. You are absolutely correct. It will be helium. And you said because it's the smallest in volume? Yeah. Yeah. What leads to the gas escaping out the hole? Right. But what causes that? So we have this balloon. Yeah. It could help. You're right. Yeah, the rapid random motion. And it's just, how likely is it to encounter the hole? Yeah. And then it's leaving. And then it's leaving. Okay, so, all right, it's the smallest, but what helps it encounter the holes more than the other gases? Go. Yes. So when you say size, helium of the gases has the lowest molar mass of the gases. Therefore, helium since it has the lower molar mass, what do we know? You could write speed. If we remember, it's that root mean square velocity has the greatest velocity. If we want, we could support it with 3RT over MM. And that is just nice evidence to support that. Okay, but so it has the greatest speed. Well, so how does that lead to the greatest deflation? Why? Because so the greater speed will lead to greater possible numbers of contact of helium with the outside or with the vessel, which increases the likelihood of it finding the hole. So it's like it leads with greater speed because which leads to a greater number of collisions with the walls, which equals a greater probability of finding the hole in balloon. So Rishi, you were correct. Helium, he said, because it's the smallest. Well, smallest in what? Lowest, we really should be talking about molar mass, although size sure does help. But it's about how often is the helium possibly encountering that exit. Okay. Concerns? Any more clarity needed? You do not have to, but it is absolutely acceptable to abbreviate, to use, dot, to use this for decrease or lower, more than fine. I know we said that, but just to illustrate again. Okay, you don't have to turn. So sorry that this packet did not deliver the page numbers. So I had asked us yesterday at the beginning of class to do the multiple choice, including 9 and 6 on the second page. But we didn't get to those yesterday, but I said, I will answer them. Yeah. So what I want to put in our hands, I'll put it on your desk when we go into lab. I made a review packet that usually I would give this to us tomorrow, but I want you to know that we have this as a resource. So this, gives us our answers. And then the next couple of pages in your packet also have, and I just gave us the answers for those. And I thought if we needed a little bit of explanation, I gave that. So in unit packet, but then not in the unit packet. So here, if you would like, are some more practice multiple choice. If you would like, you can answer. And then I've included the answers with a little bit of wording if I thought you needed it or work. I also just want to show us, I also provided just some past free response questions if you want to practice, but always an option, always an option. And we'll talk about format of our assessment tomorrow. I'll put this on your desk when we go into lab. All right, so today, we can enter lab, but we shouldn't gather materials until we've gone through and found the concentration of the potassium permanganate that you made last week. So we should have this moving forward. All right, then you are going to choose an unknown. There are 3 different unknowns. Please, please, please make note of the name. Because they're different concentrations. You know, you'll never lose points based upon, write down. If you're not close, but it should be reasonable. I'm sure we'll be totally fine. So it just helps me to just take a look at how your work compares. That's all. You will use 3 trials, 25. We get it to be 25.00. Yes, we can. Think about that. Samples of whatever you choose. 25 milliliters. So I would favor the smaller Erlenmeyers because that won't be very deep for us to judge the color change. The unknown is a solution of FAS that has been acidified. Remember last time we had to add sulfuric, we had to add phosphoric. That's already been added. You are after that. Okay, so we'll do the same thing. You'll have your unknown. Our titrant will be the potassium permanganate. And just remember, it's a little hard to judge the bottom of the meniscus. So just decide with your partners how you want to judge that. Do we want to compete today? Okay, because so what I was doing last time, so we will learn that colored species, of course, interact with visible light and ultraviolet light. That's supposed to be wavelength. And for example, Bryce's Peters Township red hoodie, yeah, we see red because it's being hit by white light, but then red is being rejected, or different wavelengths that then our eye interprets as red, yeah? So we're purple. What I do first is scan the potassium permanganate to see where does it absorb best. And so, because it's colored, I'm going to then test it at that wavelength. So when I put in your samples, that's the wavelength I'm looking at. And the smaller the absorption, the smaller the concentration. So that's why whenever I wrote down those numbers, we were targeting the smallest absorption last time with our phenolphthalein. So we'll see who can be Grand Master Champion. We have to come up with a better king or royalty of titration, royalty. We'll work on it. Just some things. Go ahead, say Prime Minister of Titration. Oh. Please don't be offended in any way, shape, or form. Was that like a French? I'm just kidding. President, Supreme Leader, whatever. All right, very good. Okay. So sorry. So, can I just present something to think about? So, there was a chemist that developed this Mohs triangle. So, I guess we could look at it like this. All right. What we experience is the macro scale, yeah? So whenever we add the volumes, we're measuring the volume, we see the color change. That's what we are experiencing. But what is going on at the particle level? So you have this solution, whole bunch of stuff. We know it has Fe+2. You are adding the permanganate. What drives this reaction? What is the driving force? Risa? Are we creating water? We know it's acidic, yeah. So maybe, yeah. And we know with our balancing that we often get water as a product or as a reactant. We can have more than one driving force. So not precip, not gas here. Transfer of electrons. So your iron begins +2, becomes +3. Michael, oxidation reduction. You got it. So this is your reducer. +7 goes to +2. This is that beautiful deep purple. This is colorless. So on the particle level, can you imagine in your Erlenmeyer that when the permanganate reacts with that, we are making then Fe+3. This, right, gives its electron, which then forms Mn+2 and so on. So if we could just allow ourselves to just think about that for a moment. And then are there any kind of equations or graphs? Well, we do the Stroik. Yeah. And oh, we're doing this to see how close to the stoichiometric point did we get. So really all the lab work that we do involves this, but sometimes it's good to be purposeful about, okay, what are we observing with our eyes? Well, what do we know is going on at the particle level? And then are we employing any kind of equations, graphs, that kind of thing? Oh, the chemical reaction balance.
For the interruption, today is photo retake day. At this time, would any seniors who were not here for the first photo day, or if you still need a formal or need a retake, please come down to the black box at this time. Any seniors who did not have an ID photo taken, need a formal or a retake, please come to the black box at this time. Thank you.
The echoing, doesn't that make it sound extra haunting? I'm not sure. Anyway, safety precautions, goggles, of course, gloves because of the permanganate. I would love whatever solution still remains, your potassium permanganate, we'll put it back in the cabinet just like we did with our sodium hydroxide solution. Any more instruction, clarity needed at all? Who gave us our chair last time? Emily, was that you? Or Dylan, right? Wait. Dylan, did you give us our chair last time? Oh, I thought. Can you remind us what? Our visitors will probably wonder what is going on. So if someone could explain, I don't know if I don't know, before like a sporting event, do the team members like bring all their hands in and then you like cheer? Is that, you guys do that too? So we do it because our game is our lab work. So I know it's so weird, but that's all right. All right. Are we doing 3, 2, 1 or 1, 2, 3? Count us down with oomph, with oomph.
Okay, goggles.